Welcome back. There's so many changes being proposed at Horizen in the DAO, but it's time to do a video series to give you an update on what's going on. I'm Rolf Versluis, co-founder of Horizen. We've had a blockchain up and running since 2017, and let's talk about all the different changes that are being proposed. So first off, we're going to talk about zero-knowledge proving and proof verification, what the purpose of it is, how it's being used in the Web3 space right now, and what the future use cases for it are going to be. That's going to set the baseline for this video series. Next, we're going to talk about the proof verification blockchain that has been proposed, what we already got in testnet, what we're already doing with other projects, and how it's going to operate in a semi-technical way. Then we're going to talk about how we're actually going to be able to move from the existing two blockchains that we're operating to the two new blockchains. Now this is a proposal, this is a bunch of different ideas. All of this has to be voted on by the Horizen DAO and then has to be funded for adoption. And then we're going to talk about the proof verification chain adopters. We've been talking to a lot of different projects out there that could really use a dedicated proof verification chain that can be accessed in a composable and modular way. So these are the different video series that we're going to do. There may be others based on questions or additional information. And as it's been a while since I've been doing these videos, don't worry, the video and sound quality is going to get better as we proceed. So looking forward to this. Let's go. Let's talk about how zero-knowledge proofs are currently used in Web3. So what do? Well, zero-knowledge proofs are a mathematical way to verify a computation. I'll give you an example. So when you log into your bank account, you see that you got a bunch of transactions, money coming in, money coming out, and you see you got a balance. Now you had a balance in your bank account 5 years ago also. So how do you know that all those money going in and out of your bank account from 5 years ago is properly added and subtracted to your existing balance? Well, most of you probably do what I do, is we just trust that the bank did the computation correctly. Trust is an okay way to do things in a highly regulated environment, possibly. But there's another way that you can do it. Some of you might remember people who used to balance their checkbooks. For every check that they wrote and every deposit that they made, they would add and subtract those themselves. So in addition to seeing what the bank did with their bank balances, they also did the calculations themselves to verify it. So you can trust the organization that's doing the transactions, or you can run all the computations yourself. Now with zero-knowledge proofs, there's actually a third way of figuring out that the balance is correct. So it's possible, using advanced cryptographic techniques, to prove that those transactions are all correct without sharing the underlying transactions. That's the secret beauty of zero-knowledge proofs. And it can be applied in many different ways, especially in the Web3 and blockchain environment, which is set up to be decentralized, and we don't want to have a single trusted organization that we have to depend on for everything to operate. So a zero-knowledge proof, just understand that the basic idea is to use advanced mathematics to verify that a computation happened without having to share all the existing, all the transactions. Okay? So how are they used in Web3? Well, right now, the main way that they're used in Web3 is to extend the capability of Ethereum. And this is done in zero-knowledge proof rollups, so ZK rollups. The way that the ZK rollups work, it might be Linnea or ZK Sync or Polygon has a ZK EVM. They operate a bunch of transactions on their blockchain, and then periodically take all the transactions and summarize the changes to the accounts. Then they create a zero-knowledge proof proving that those transactions were valid for making those account changes, and they post both of those to Ethereum. So the account changes to the Ethereum accounts get posted to Ethereum, and then a validity proof that verifies that those transactions are correct are sent to Ethereum as well. Now right now, that validity proof is verified, because in order to have a zero-knowledge proof prove that something is true, or is as true as you can believe it to be, you have to generate the proof, and then the proof has to be verified. There's two parts. So that proof is currently, for the ZK rollups, being verified on Ethereum in Solidity. It's kind of expensive for the ZK rollups to do that, but they're able to modify the mathematics of how the proofs are done and aggregate additional proofs together, so the cost isn't really that bad for the big ZK proofs. So that's just the tip of the iceberg, how zero-knowledge proofs can be used within Web3. So ZK rollups are one of the ways that they're used, but let's talk about the generation and the verification of it. So here's a drawing representing the amount of computation that's done right now in many of the ZK systems used in Web3. Because the biggest use case currently is for ZK rollups, and it's so expensive to do the verification on Ethereum, there's been a lot of mathematical optimization to reduce the amount of computation needed to be done on the verification side of things. So this has put more burden on the proving side of things. It means that when when the zero-knowledge proof is created, there has to be a lot of server computation being done. In fact, there's people that are setting up systems to be able to use graphical processing unit to do the ZK proving, as well as specific ASICs for proving. So this is an expensive part of the ZK proof verification. But ZK rollups are not the only thing that zero-knowledge proofs can be used for. They can be used for proving any type of computation. So you think about, all right, what are some of the things that I might want to use these zero-knowledge proofs for? Well, you can also use it to do selective disclosure of information. So say that you wanted to be able to vote in a DAO, but you didn't want people to see what your Ethereum address is, because then they could maybe dox you and influence your future vote. So one of the things over the years that the cryptographers at Horizen Labs has developed is a voting system that can prove that your vote was counted. You can go look it up on the blockchain, but it hides your address. So this type of selective disclosure is really important, especially as the votes that different DAOs do become more and more important in a wealth sense or a governance sense. In fact, I believe that DAOs are really one of the huge creations that are going to become bigger than countries, that are going to become bigger than most businesses, and really going to be a way that we're going to be able to govern ourselves in the future. So people that have ideas or specific likes or dislikes can join the different DAOs that do those. In fact, Horizen is now governed by a DAO, so any of these things that I'm talking about that people are talking about Horizen doing, all have to go through a Zen IP process, and they have to be voted on by the DAO. Another thing that you can do with zero-knowledge proofs and being able to verify the computation is you can, through selective disclosure, use it in a different situation. So imagine an online game of blackjack. Now, if you think about blackjack at a casino, you got maybe 5 people sitting at a table and a dealer, and then you got maybe 5 or 7 decks of cards in a shoe. And you don't know what those cards are. And some of those cards are dealt to the table. Some of them are flipped over, but some of them are kept hidden. So that's another type of verifiable computation with selective disclosure that a zero-knowledge proof could do. It could calculate what those cards are, prove that those cards haven't been meddled with, but it can prevent people from looking on the block explorer to see what those cards are. Now, to be able to do these types of fog of war for gaming or private voting or those types of things, we need to change the way that the zero-knowledge proofs are done to be able to get them to be done faster and less expensively. So one of the things, as we move away from zero-knowledge rollups being the primary method or the primary use case for ZK proofs, we can move to different types of mathematics that allow the proofs to be generated quickly with less computation, and we can offload some of the computation to the verifier. Now, how do we offload some of the computation to the verifier? Well, we have to stop doing the proof verification on Ethereum in Solidity because that's expensive and slow. So, and I'll talk about this in another video, but one of the things that we're looking to do at Horizen is to have a proof verification chain which is optimized for doing proof verifications. So with each different type of ZK proof that's generated, it could be a snark, it could be a stark, and within the snark realm, it could be Groth 16 or Boojum or all sorts of different types of starks and snarks. We'll get into that in another video. We write a verifier that verifies that particular type of computation, and we write it in Rust, so it's highly optimized, much less computation. And then we make sure that the validators that are doing the computation are of a certain level that they can compute these things very quickly. And that type of improved zero-knowledge proof for other applications than ZK Rollup is what we're looking to do as we move forward with the Horizen proof verification chain.